What would happen if an object coming from the depths of interstellar space, after traveling billions of kilometers in complete darkness, performed a maneuver so precise that it defied everything we believe we know about the physics of the universe? Stay until the end, because what you are about to hear could forever change the way you look at the night sky. This is the story of a visitor that should not exist, of a trajectory that should not be possible, and of a mystery that keeps more than 200 observatories around the world on edge.
Good evening, dear audience. Felipe Suarez here, accompanying you as always on this journey through the far reaches of the cosmos. And let me ask you something before we continue. Have you ever thrown a rock at a distant target and missed by a lot? Now, imagine throwing that rock from another galaxy and hitting with millimetric precision. Sounds impossible, right? Well, that is exactly what is happening right now in our solar system. An object called 3I Atlas is doing something no natural comet has ever achieved.
It all began the way great stories of modern astronomy usually begin, with an almost imperceptible flash on a telescope's screens. Automated space surveillance systems detected something moving at an unusual speed, crossing the void with a determination that caught scientists' attention from the very first moment. It was not a common asteroid. It was not a comet from the Kuiper Belt. It was nothing that belonged to our cosmic neighborhood. It was an intruder, a traveler that had been born in some remote corner of the galaxy, and that for reasons we still do not fully understand, had decided to visit our small planetary system. The first analyses confirmed what many had suspected from the beginning. The object's trajectory was hyperbolic, an open curve that indicated without a doubt its extrasolar origin. It came from outside, from very far away, from a place where no human telescope has been able to look clearly. Its entry velocity far exceeded the solar system's escape velocity, which meant it was not trapped by the sun's gravity. It was simply passing through, like a cosmic tourist crossing a city without stopping for too long. But there was something different about this visitor, something that astronomers took weeks to identify with certainty, but that once discovered, completely changed the nature of the investigation. The object was not behaving the way a natural body subjected only to the gravitational forces of the solar system should behave. There was something else acting upon it, something producing small but constant accelerations that did not fit any known model. At first, scientists assumed it was the phenomenon known as outgassing, a completely normal process in comets approaching the sun. When surface ice is heated by solar radiation, it sublimates directly into the vacuum of space, creating jets of gas that can push the comet in unexpected directions. It is a well-studied mechanism, perfectly understood, that explains many of the irregularities observed in cometary orbits. However, outgassing has a distinctive characteristic that was not present in 3I Atlas. Gas jets are chaotic by nature. They emerge from random cracks on the surface, activate and deactivate without a predictable pattern, and produce erratic movements that make the comet spin, wobble, and describe trajectories full of small, unpredictable jumps. It is a disorderly dance, a choreography-less ballet that leaves unmistakable traces in tracking data. But Atlas was not dancing like that. Atlas moved with a disconcerting calm, with a stability that did not correspond to a natural body subjected to random forces. Its acceleration was constant, smooth, almost imperceptible in each individual measurement, but perfectly consistent when entire weeks of observations were analyzed. There were no sudden jumps, no abrupt changes in direction, none of the typical signs of an object governed by the chaos of natural outgassing. And then came the moment that changed everything. The perihelion passage, the point of closest approach to the sun, that critical instant where any celestial body experiences the most intense forces of its entire orbital journey. Normal comets usually show their greatest activity during this phase, releasing enormous amounts of gas and dust that form the spectacular tales we so admire from Earth. But Atlas did something different, something that left researchers speechless. Just after passing through perihelion, the object experienced a trajectory change as subtle as it was significant. It was not a dramatic deviation. It was not an abrupt turn that could be attributed to fragmentation or a gas explosion. It was a delicate adjustment, almost surgical, that slightly modified its course in a very specific way. And when astronomers calculated where the new trajectory was now pointing, they were left completely frozen.
Hey, wait a moment. Are you telling me that a chunk of rock and ice coming from who knows where, after traveling for millions of years through empty space, suddenly decided to change course at precisely the right moment? That sounds like science fiction, my friend. What do you think? Do you believe nature can be that precise? Or is there something fishy going on here? Because let me tell you, what comes next is going to give you goosebumps. The direction Atlas is pointing toward is not just any place in the solar system.
The new trajectory of 3I Atlas pointed directly toward one of the most significant locations from an orbital mechanics standpoint, the boundary of Jupiter's Hill sphere. To understand the importance of this discovery, we first need to understand exactly what the Hill sphere is and why it represents such a fundamental boundary in solar system dynamics. Every massive body in the universe exerts a gravitational influence on its surroundings. The Sun, being the central star of our system, gravitationally dominates all the planets, asteroids, and comets that orbit around it. However, each planet also has its own zone of influence, a region of space where its gravity is stronger than the Sun's for practical purposes. This region is known as the Hill sphere, named after American astronomer George William Hill, who developed the equations that allow us to calculate its extent. Jupiter's Hill sphere is particularly important because Jupiter is by far the most massive planet in the entire solar system. With a mass equivalent to more than 300 Earths, the gas giant exerts an enormous gravitational influence on everything that passes near it. Its Hill sphere extends approximately 53 million kilometers in all directions, creating an invisible bubble where the rules of gravitational play change drastically. Within this sphere, Jupiter is king. Any object that enters this region becomes subjected primarily to the planet's gravity, not the Sun's. This means it can be captured into orbit, violently deflected in another direction, or even expelled from the solar system at a much greater velocity than it originally had. It is a transition zone, a threshold where the fate of cosmic visitors can change radically in a matter of hours. And here is the detail that has left scientists around the world perplexed. 3I Atlas is not heading toward just any point within Jupiter's Hill sphere. It is not pointing toward the center of the planet as an object attracted by its gravity would. Nor is it heading toward a typical capture orbit, like those followed by comets that occasionally become trapped by Jupiter. Atlas is pointing directly toward the very edge of the sphere, toward that invisible boundary where the planet's gravity and the Sun's gravity balance in a delicate cosmic tie. The precision of this alignment is what has caused so many researchers to lose sleep. We are talking about a margin of error of barely 35 kilometers in a journey of billions of kilometers. To put it in perspective, imagine shooting an arrow from Mexico City and hitting exactly the edge of a coin placed in Buenos Aires. Now imagine that arrow travels for millions of years, crossing radiation storms, changing gravitational fields, and the most absolute vacuum of interstellar space. And still, it arrives exactly where it was supposed to arrive. More than 230 observatories spread across the entire planet have independently confirmed this trajectory. Telescopes in Chile, in Hawaii, in the Canary Islands, in South Africa, in Australia, radio telescopes detecting the object's microwave emissions, space probes that have adjusted their instruments to follow its movement. They all agree on the same thing. The precision is real. It is not a measurement error. It is not an instrument artifact. Atlas really is heading toward that specific point with an accuracy that defies all conventional explanation.
Look, I have been telling stories about the cosmos for many years, and I can assure you I have never heard anything like this. 230 observatories, friends. We are not talking about a couple of crazy scientists with homemade telescopes. We are talking about the entire global astronomical community looking at the same point and seeing exactly the same thing. Do you know how hard it is to get that many scientists to agree? Well, here there is no possible debate. The numbers do not lie, and the numbers say something very strange is happening up there.
The date everyone has marked in red on their calendars is March 16th, 2026. On that day, according to the most recent calculations, 3I Atlas will reach the point of closest approach to the boundary of Jupiter's Hill sphere. It will be the moment of truth, the instant when all theories will be put to the test, and when the object will finally reveal its true nature. Astronomers have prepared an unprecedented battery of instruments to observe this encounter. Space telescopes like the James Webb have reserved exclusive observation time to follow every detail of the approach. Ground-based observatories on every continent will coordinate their efforts to maintain continuous surveillance during the critical weeks before and after the encounter. Even some space probes currently on mission have received instructions to slightly modify their programs to contribute to the observation. But while we wait for that date, scientists have not stopped analyzing every fragment of available information about Atlas's behavior, and what they have found has only deepened the mystery instead of resolving it. One of the most disconcerting aspects is the stability of the observed trajectory. Under normal conditions, any object experiencing non-gravitational forces, such as solar radiation pressure or outgassing, should show fluctuations in its movement. Small variations that accumulate over time and make long-term predictions increasingly less precise. It is what astronomers call error propagation, an inevitable phenomenon when working with complex dynamic systems. But Atlas is doing exactly the opposite. With each new observation, with each new measurement, the margin of error in predictions shrinks instead of growing. It is as if the object were following an invisible line drawn with ruler and compass, a predetermined route that admits no deviations. Every time telescopes look at it, it is exactly where it should be. Not a little to the left, not a little to the right, exactly where calculations predict it should be found. This characteristic has led some researchers to compare Atlas's movement to that of a controlled spacecraft. When space agencies launch probes toward distant planets, they use navigation techniques that require periodic corrections to maintain the desired trajectory. These corrections are necessary because space is full of subtle influences that can divert a craft from its original course. Solar wind, radiation pressure, small variations in gravitational fields. Everything adds up. Everything has an effect. Everything requires compensation. Human probes make these corrections through small rockets called maneuvering thrusters. They fire for fractions of a second, release minuscule amounts of fuel, and adjust the craft's velocity and direction with millimetric precision. It is a delicate process requiring constant calculations and permanent communication with control centers on Earth. And here is the question. No one wants to ask out loud, but everyone has in mind. If Atlas moves like a controlled craft, does that mean someone or something is controlling it?
Whoa, everyone calm down. I know what you are thinking. Felipe, are you telling us there are aliens piloting that thing? Easy. No one has said that yet. But no one can completely rule it out either, and that is what has scientists biting their nails. Because look, one thing is for a comet to do strange things, that happens all the time, but quite another is for it to do them with this precision. Have you ever tried to park a car in a very tight space? Imagine doing that on a cosmic scale.
To maintain scientific objectivity, researchers have developed 4 main hypotheses attempting to explain the anomalous behavior of 3I Atlas. Each has its defenders, each has its problems, and none has managed to completely convince the scientific community. The first hypothesis, and perhaps the most conservative, suggests we are witnessing an extreme case of accumulated observation errors. According to this theory, The apparent precision of Atlas's trajectory would actually be an illusion created by systematic biases in measurement instruments. Different telescopes could be making similar errors that, when combined, create the false impression of a perfectly aligned trajectory. However, this hypothesis has a fundamental problem. The more than 230 observatories that have confirmed the trajectory use very different technologies from each other. Traditional optical telescopes, radio telescopes, infrared detectors, very long baseline interferometers. It is extremely unlikely that all these systems, designed and built by different teams in different countries, would commit exactly the same type of error in exactly the same direction. Furthermore, each new observation refines the precision instead of revealing discrepancies, which directly contradicts what we would expect if there were significant systematic errors. The second hypothesis proposes an extraordinarily orderly outgassing mechanism. According to this theory, Atlas's surface could have a very particular configuration that produces gas jets in a single consistent direction. Imagine a sphere with a single large crack oriented in a specific way. When the sun heats that crack, the gas always escapes in the same direction, producing a constant and predictable thrust. This explanation has certain theoretical appeal, but faces important objections. To produce the observed acceleration over the observed time, the crack would have to maintain its orientation and intensity with almost impossible consistency. Any variation in the object's rotation, any change in the composition of exposed ice, any irregularity in solar heating would have produced detectable deviations, and there are none. The trajectory remains clean, stable, imperturbable. The third hypothesis appeals to pure statistical coincidence. The universe is vast, time is long, and improbable things happen all the time, simply because there are enough opportunities for them to occur. Perhaps Atlas is simply the winner of a cosmic lottery, an object that by pure chance ended up with exactly the velocity, direction, and composition necessary to follow this apparently perfect trajectory. Defenders of this hypothesis point out that many other interstellar objects have probably passed through the solar system without us detecting them. Before the development of modern surveillance telescopes, the vast majority of these visitors would have crossed our cosmic neighborhood without leaving a trace in human records. If thousands or millions of similar objects have passed before, it would not be so surprising that one of them showed statistically extreme behavior. But even the most generous statisticians acknowledge that the numbers do not quite add up. The level of precision observed is so extraordinary that it would require a number of previous attempts exceeding the most optimistic estimates of interstellar object flux. It is like winning the lottery 10 times in a row. Technically possible, but improbable enough to justify the search for alternative explanations.
And here we arrive at the fourth hypothesis, friends, the one no one wants to mention at press conferences, but everyone discusses in the hallways after symposiums, the possibility that Atlas's movement is not completely natural. Mind you, this does not necessarily mean spaceships or alien civilizations. It could be something more subtle, something our physics still does not understand. But the question is there, floating in the air like Atlas itself floats in the void? What if someone designed this?
The fourth hypothesis is, by far, the most controversial and the most fascinating. It proposes that the movement of 3I Atlas could respond to some type of control or design, whether completely artificial or based on natural mechanisms we do not yet understand. The more cautious scientists prefer to focus on the second possibility. Perhaps Atlas is made of exotic materials that interact with sunlight in ways we have not observed before. Perhaps it has an internal structure that produces ordered reaction forces in response to temperature changes. Perhaps there exists some unknown physical phenomenon that can produce passive navigation through complex gravitational fields. These explanations have the advantage of not requiring intelligence or deliberate design. They would simply be new forms of physics, waiting to be discovered and understood. The history of science is full of phenomena that seemed magical or impossible until we found the correct equations to describe them. Perhaps Atlas is simply the next chapter in that long history of discoveries. But there are those who dare to go further. Some researchers, generally speaking unofficially, have pointed out that Atlas's behavior is exactly what we would expect from an interstellar probe designed to efficiently explore planetary systems. The gravitational assist maneuver it is apparently executing is a well-known technique in human space navigation. Our own probes, like Voyager, Pioneer, and New Horizons, have used close encounters with giant planets to gain speed and change direction without expending fuel. The difference is that our probes require careful planning, precise calculations, and constant course corrections to execute these maneuvers correctly. A natural object should not be able to do it spontaneously, unless, of course, it is not completely natural. There is an additional detail that fuels these speculations. The exact point toward which Atlas is heading, the edge of Jupiter's Hill sphere, is not a random destination. It is precisely the place an intelligent probe would choose to position itself if it wanted to maximize its future navigation options. From that gravitational equilibrium point, the object could choose among multiple possible trajectories with minimal energy expenditure. It could head toward the inner solar system, toward the outer regions, or even remain in a stable orbit around Jupiter for prolonged observation. It is, in other words, a strategic point, a place where a cosmic explorer would have maximum flexibility to decide its next move.
Hold on a moment there, because this is getting good. Are you telling me Atlas could be positioning itself to make a decision? Like when you arrive at a roundabout and can choose which exit to take. Look, I am not a scientist, but that sounds like intelligent behavior, not like a space rock wandering around. Do you believe we are alone in this vast universe? Because stories like this make you question many things you took for granted. Think about it while we continue with the story.
While the debate about Atlas's nature continues in laboratories and universities around the world, astronomers are already preparing scenarios for what could happen when the object finally reaches the boundary of Jupiter's Hill sphere. There are three main possibilities that concentrate the scientific community's attention, and each of them would have profound implications for our understanding of the interstellar visitor. The first scenario is fragmentation. The transition zone between the Sun's gravitational influence and Jupiter's is a place of extreme stresses. Tidal forces, those subtle differences in gravitational intensity between one side of an object and the other, can be surprisingly destructive to bodies with weak or fractured internal structures. Many comets have broken into pieces when passing near giant planets. The most famous case was comet Shoemaker-Levy 9, which fragmented into more than 20 pieces before spectacularly impacting Jupiter's atmosphere in 1994. If Atlas suffered a similar fate, we could witness one of the most revealing astronomical events of recent decades. Fragmentation would expose the object's interior for the first time. We could see hidden layers, internal cavities, materials that have remained protected from space radiation for millions of years. Telescope spectrometers could analyze the chemical composition of these pristine regions, revealing invaluable information about the conditions that existed in the stellar system where Atlas originally formed. And here is the most intriguing aspect. If Atlas is not completely natural, if it has some type of design structure in its interior, fragmentation could reveal it unequivocally. Metallic components, artificial geometries, materials that could not form through natural processes. It would be the definitive evidence that would solve the mystery once and for all. Of course, it could also fragment and reveal simply more rock and ice, exactly what we would expect from an ordinary comet. That would also be valuable information, though perhaps less exciting for those hoping for confirmation of extraterrestrial visitors. The second scenario contemplates the controlled release of fragments. Some researchers have noted that Atlas could shed parts of itself selectively when crossing zones of particular gravitational stress. This is different from catastrophic fragmentation. These would be small ejections of material, almost as if the object were shedding unnecessary ballast. If these fragments followed predictable and stable trajectories, It would be a very significant sign. Natural objects that lose fragments do so chaotically, with pieces flying in all directions without a recognizable pattern. But if Atlas's fragments formed some type of ordered formation, or followed routes suggesting intentionality, we would have to seriously reconsider all our assumptions about its nature. Some bolder scientists have speculated that this fragment release could be a communication mechanism. Perhaps Atlas is leaving a trail of small objects containing encoded information, like the bottles with messages that castaways threw into the sea, hoping someone would find them. It is a speculative idea, no doubt, but no more speculative than other hypotheses attempting to explain the observed behavior.
Wait. Space bottles with messages? Now that really sounds like a good science fiction movie, but think about it for a moment. If you were an advanced civilization and wanted to explore the galaxy, would it not make sense to send probes that could leave markers in the systems they visit, like when ancient explorers left signs on paths for those who would come after? I am not saying that is what it is, but the idea has its logic, do you not think? The universe is too big to travel through without leaving a trace.
The third scenario is perhaps the most bewildering of all. It contemplates the possibility that Atlas will change direction significantly when crossing the Hill-sphere boundary, but not toward where physics predicts it should go. According to the laws of orbital mechanics, when an object crosses the gravitational influence boundary of a massive planet, its trajectory should be modified in very specific and calculable ways. Depending on its velocity and approach angle, it could be captured into orbit, deflected in a particular direction, or expelled with additional velocity gained from the planet's angular momentum. All these options are predictable with high precision once we know the initial conditions. But if Atlas did something different, if its trajectory after the encounter did not correspond to any of the calculated options, we would have almost definitive evidence that unconventional forces are acting upon it. A direction change that violates conservation of momentum, a deceleration without apparent cause, an entry into orbit with impossible parameters. Any of these results would revolutionize our understanding of the object and possibly of physics itself. The more conservative scientists insist we must wait and observe before drawing hasty conclusions. The universe is full of phenomena that seem impossible until we understand them better. Perhaps Atlas is simply showing us natural processes we had never had the opportunity to observe before. Perhaps there are natural propulsion mechanisms based on interactions with magnetic fields or solar wind particles that can produce apparently controlled movements in objects with the right composition. But even these cautious scientists acknowledge that what is happening with Atlas is extraordinary. In the entire history of observational astronomy, we have never seen an interstellar object behave this way. Not even Oumuamua, the first confirmed interstellar visitor we detected in 2017, showed this level of trajectory precision. Oumuamua had its own list of anomalies, including a similar non-gravitational acceleration, but its course was much more erratic, much less focused than that of Atlas. This suggests that if both objects are natural, they represent very different types of formation and evolution. And if one or both have non-natural origins, they could represent different designs, different purposes, different creator civilizations. The possibilities are as vast as the space these objects have crossed to reach us.
You know what all this makes me think about, dear audience? If there really is someone or something sending probes to explore the galaxy, we have been receiving visits for millions of years without realizing it. Think about all the objects that must have passed before we had telescopes, before we even knew that other suns existed besides our own. How many atlases will have crossed our sky without anyone seeing them? How many messages will we have missed simply because we were not looking? It is enough to keep you awake at night, honestly.
The wait until March of 2026 has become one of the most tense in recent astronomical history. Every passing day, telescopes around the world continue tracking the position of 3I Atlas, refining predictions, searching for any sign of change in its apparently perfect behavior. Research centers have established special protocols to share information in real time. When an observatory in Chile finishes its night of observation, the data is instantly transmitted to telescopes in Asia that are beginning theirs. And when Asia finishes, European observatories take over. It is a continuous chain of surveillance that keeps the object under observation practically 24 hours a day. This unprecedented coordination has produced the most detailed data set we have ever had on an interstellar object. We know its velocity with precision down to centimeters per second. We know its position with precision down to kilometers. We know its brightness, its color, its surface temperature, its rotation rate. And each of these data points confirms the same thing. Atlas continues on its course without deviation, like a train advancing on invisible tracks laid across the vacuum of space. Astronomers have begun informally referring to this trajectory as the Atlas lane, implicitly recognizing that the object seems to be following a predetermined route, rather than simply drifting under the influence of random forces. It is a description some consider too anthropomorphic, attributing intentionality to what could simply be unknown physics. But it is difficult to observe the object's behavior and not have that impression. Meanwhile, theorists have not stopped working on models that could explain what has been observed. Dozens of potential mechanisms have been proposed, from interactions with the interplanetary magnetic field to exotic quantum effects that could produce propulsion at macroscopic scales. None has managed to exactly reproduce the observed behavior, but each failed attempt teaches us something new about the limitations of our current physics. There are those who argue the problem is not in our theories, but in our data. Perhaps there are systematic errors we have not detected yet. Perhaps the apparent precision of the trajectory is an illusion produced by some bias in our analysis methods. But with each new observatory confirming the results, with each new verification technique producing the same numbers, this possibility becomes less and less credible. The scientific community finds itself in an uncomfortable position. The data says one thing, but that thing does not fit any satisfactory explanation. It is like having all the pieces of a puzzle except the central one, the one that would make sense of the whole. We know Atlas is doing something extraordinary. We simply do not know how or why.
Felipe Suarez here, friends, finishing telling you this incredible story that is happening right now above our heads. I do not know about you, but I am going to be glued to the news when next March arrives. This is too important to miss, and I want you to accompany me on this journey, that we follow this mystery together wherever it takes us. Because whatever happens, we are going to remember this moment. We are going to remember where we were when Atlas reached Jupiter.
The night remains the same as it has been for billions of years. The stars shine with the same ancient light that illuminated the skies when our most remote ancestors looked up from the African plains. The universe continues its silent expansion, indifferent to the small creatures who, from a blue planet lost in the outskirts of a spiral galaxy, try to understand its mysteries. But something has changed. Now we know there are visitors, objects that cross the vast abyss between stars and pass through our solar system on their incomprehensibly long journeys. Perhaps they were always there, crossing space without witnesses, fulfilling purposes unknown to us. But now we see them. Now we can study them. Now we can ask ourselves what they are and where they come from. 3i Atlas is just the most recent of these cosmic messengers, but it is without doubt the most enigmatic. Its impossibly precise trajectory, its inexplicably orderly behavior, its direct course toward one of the most significant points in our solar system. Everything about it defies expectations. Everything raises questions we do not know how to answer. And perhaps that is the most valuable thing of all. Not the answers we may eventually obtain, but the questions Atlas has forced us to ask. Questions about the nature of interstellar objects. Questions about the limits of known physics. Questions about the possibility of extraterrestrial intelligence. Questions, ultimately, about our place in a universe that turns out to be much stranger and more wonderful than we ever imagined. The story of Atlas is just beginning. There are chapters that have not been written yet, revelations waiting in the near future, surprises no model can predict. And we, the humble witnesses of this cosmic drama, have the privilege of observing as it unfolds. The night sky will never be the same after Atlas. Every time we look up, we will remember that among those distant stars, there are objects traveling, crossing the void, following routes that perhaps someone traced millions of years ago. And we will wonder, inevitably, whether someday one of those travelers will bring answers to the questions humanity has asked since it became aware of its own existence. Are we alone? Is there someone else out there? Is the universe alive with intelligences that explore and search and ask themselves the same things we do? Atlas has not answered these questions yet, but perhaps when it crosses the invisible boundary of Jupiter's hill sphere, it will bring us a little closer to those answers we so long for. Until then, we will keep watching, we will keep waiting, we will keep dreaming of the stars, as we have done since the beginning of time.
And with this, we say goodbye for today, dear audience. Thank you for accompanying me on this journey through the stars. If this story has made you think, if it has reminded you of something from your own life, perhaps that time you looked at the sky and felt something inexplicable, let me know in the comments. I love reading your experiences and knowing I am not the only one who gets excited about these mysteries of the cosmos. Subscribe so you do not miss the updates on Atlas, because this is just beginning. And remember, my friend, the universe is too big for us to be alone. Until next time.
The silence of interstellar space holds secrets we are only beginning to glimpse. Somewhere between the orbits of the giant planets, an object come from the depths of the galaxy continues its imperturbable journey, oblivious to the millions of eyes watching it from Earth. It does not know, or perhaps it does know, that its presence has awakened something in the dominant species of this small rocky world, a mixture of curiosity, wonder, and hope that defines the best of what it means to be human. 3i Atlas will keep advancing, following the mysterious trajectory that has brought it here, and we will keep watching, questioning, seeking to understand, because that is what we do, that is what we are. Explorers by nature, seekers of answers in a universe that seems designed to pose infinite questions. March 16th, 2026 is not just a date on the calendar, it is an appointment with the unknown, a unique opportunity to witness something we may never see again in our lifetimes. And whatever happens that day, we will have been part of something greater than ourselves. We will have been witnesses to the moment when a messenger from the stars crossed the invisible boundary of our giant gaseous neighbor. The story continues to be written, the mystery remains open, and the universe, as always, keeps its deepest secrets for those who have the patience and curiosity to seek them. Atlas travels. We wait. The cosmos observes in silence, and somewhere, perhaps, someone else is also watching.